So far, we have defined a circle, looked at some of the circle's special properties, and have plotted circles on the coordinate plane. In this lesson, we will study how angles relate to circles and the formation of arcs. If you recall from the beginning of geometry, we studied the angle, a geometric figure formed by two rays traveling from a common vertex. Angles are very important in the study of circles and are related to many theorems. The central angle will be our main angle of study for this lesson. Central angles are formed by two radii with their vertex located at the center of the circle. There are infinitely many central angles that could be formed inside a circle. However, the sum of measures of all non-overlapping central angles of a circle total 360 degrees. As you can see from circle A, there are 4 central angles measuring 90 degrees. 4 times 90 equals 360. Every non-overlapping central angle of a circle will always have a sum of measures totaling 360 degrees. With each angle that is drawn on a circle, an arc is formed. An arc is a portion of a circle, starting from one point on the curve and ending at another. Arcs are labeled using the 2 or 3 points on the circle that are used to define the arc. For instance, on circle W, this is arc XY. Notice the arc symbol above the label. This is how we refer to arcs in writing. A problem quickly arises, however, in our labeling system. Which arc is considered arc XY, the smaller arc or the larger arc? Using a third point on the circle can help us differentiate between the two arcs. The smaller arc XY does not contain point Z, while the larger arc XZY does. It's important to note that the symbol for an arc, like XZY, must list the points in order of appearance, which in our case is XZY. Therefore, the symbol for this particular arc will be arc XZY. Arcs XY and XZY are examples of two kinds of arcs, minor arcs and major arcs. A minor arc is the shortest arc defined by 2 endpoints, while the major arc is the longest arc defined by the same 2 endpoints. Arc XY is the minor arc, while arc XZY is the major arc. Arcs are measured using 2 different units, degrees and radians, which is referred to as arc measure. We will revisit radians towards the end of the lesson. For now, look back at arc XY. The central angle, XWY, has a measure of 45 degrees. As it turns out, the measure of an arc is equivalent to the angle measure of an arc's central angle. The measure of arc XY is equal to 45 degrees. Minor arcs are always less than 180 degrees, while major arcs are always equivalent to 360 degrees, minus the angle measure of its related minor arc. Therefore, the major arc XZY is equivalent to 360 minus 45, equaling 315 degrees. What about arcs with a measure of 180 degrees? These arcs are called semicircles, which are arcs that have an endpoint on each end of a diameter. Semicircles always measure 180 degrees. Again, when differentiating between arcs, having a third point along the curve helps with labeling the 2 semicircles formed by a diameter. This is an example of semicircle SR and semicircle SQR. Next, we will discuss other arc properties. Arcs are considered adjacent arcs if and only if they share one point in common. Looking at circle E, we see that arcs AB and BC are adjacent to one another, since they both share point B. However, arcs AB and CD are not adjacent, since they share no points in common. Adjacent arcs have a postulate that relates to their combined angle measures, called the adjacent arcs postulate. This postulate states that arcs formed by 2 adjacent arcs have a measure equal to the sum of the measures of both arcs. For example, arc ABC has a measure of 210 degrees, since the measure of arc AB equals 120, and the arc BC measures 90 degrees, which, when added together, results in 210 degrees. You may notice that arcs AB and CD have the same angle measures. This means that these 2 arcs are congruent. Congruent arcs are arcs with equivalent measures, regardless if they are on the same circle. Arc GH of circle F is also congruent with arcs AB and CD, since arc GH also measures 120 degrees, despite not being located on the same circle. So far, we have seen that arcs have measures. which can be measured in degrees. But what about the length of the arc itself? This length is aptly called arc length, and it is measured in our standard units of measurement, like centimeters or inches. The formula for the length of an arc is L equals x divided by 360 times 2 pi r, where L represents the length of the arc, x represents the measure of the central angle of the arc, and r equals the radius of the circle the arc is on. For example, since the measure of angle AEB is 120 degrees, and the length of line segment AE is 3 centimeters, then the length of arc AB is equal to 120 over 360 times 2 pi times 3. 120 over 360 is equal to 1/3, and our equation can be simplified to 2 pi times 3 over 3. The 3's will cancel, and 2 times pi equals approximately 6.28 centimeters. However, to keep our numbers simple, foregoing the multiplication of pi will simplify our answer, and keep our answer more exact. 2 pi will suffice. Earlier in the lesson, I mentioned that the measure of an arc can be measured using degrees and another unit called radians. Radians are commonly used in more complex mathematics and function as a more concise substitute for degrees in some mathematical equations. And now that we have covered arc length, we can understand the formula for calculating radians. The formula to determine the measure of an arc in radians is theta equals L divided by r, where L again represents the arc length and r represents the radius of the circle. The new symbol, theta, is a Greek letter that is used to describe angle measures. Going back to our example with circle E, we can calculate the measure of arc AB in radians. Earlier, we determined that the length of arc AB was 2 pi centimeters. Plugging this and our radius into our formula, theta equals L over r, we get theta equals 2 pi over 3. Our equation can simplify to theta equals 2/3 pi, and the measure of arc AB in radians is simply 2/3 the value of pi. We will end the lesson by discussing how to calculate the area of a sector of a circle, which is the region bounded by a central angle and its arc. The formula for a sector is A equals x over 360 times pi r squared. A represents the area of the sector, x represents the angle measure of the central angle, and r represents the radius. If we revisit circle E and desire to calculate the area of the sector formed by angle AEB and arc AB, then using 120 degrees for x, 3 centimeters for r, our formula becomes A equals 120 divided by 360 times pi times 3 squared. 120 divided by 360 simplifies to 1/3, and 3 squared is 9. Multiplying 1/3 and 9 gives us 3, simplifying our equation to A equals 3 pi. The area of our sector is equal to 3 pi square centimeters. This concludes our lesson on central angles and arcs. Next, we will examine arcs not related to central angles and theorems involving chords of a circle.